Let's look at this solution now. Two vessels A and B contain mixture of milk and water in the ratio 4:9 and 3:11 respectively. If the contents of these two vessels are mixed, which of the following cannot be the ratio of milk and water in the mixture thus formed? Okay, this is a very simple ratio based question. Can you see in percentage terms, this will turn out to be 44.44%. And here this will turn out to be 27.27%. If any ratio that you get lies between these two values, it is a possible ratio to get. If it lies outside these two values, it is not a possible ratio to get. When you have 5/14, the ratio is something around, or the percentage number is something around 35.x%. And yes, this is possible. 7/16 is 43.75%. Lies within this range. Yes, this is also possible. 13/40 is 32.5%. Yes, this is also possible. But 11/23 is something more than how much? Slightly less than 50%. Let's just say it is 1100 divided by 23. So you get 492, 180, 47, 161, 19, 47 point something something, which is out of this range. You cannot mix two things which are having percentage figures as 44.44 and 27.27%, and then get something which is 47 point something as the final ratio. Therefore, the answer to this question has to be option D. Next question. 4 friends, Bala, Chandu, Deb, and Isha went for a movie. Total expenses incurred was divided among the 4 friends in the following manner. Bala paid 33.33% of the expenses incurred by the other 3 friends. So see, Bala, if he paid X, the other 3, Chandu, Deb, and Isha, paid 3x. So can I say the total expense, total, was 4x? Next, we are told Chandu paid 25% of expenses incurred by the other 3 friends. So if Chandu paid Y, Bala plus Deb plus Isha paid 4y, or total expenses paid by all 4 of them would be 5y. Okay. Next, they paid 45.45%. This I expect you to know to be 5/11. So if they've paid 5z, Bala plus Chandu plus Isha paid 11z, or total expense would be 16z. So now I have to find the total expense number, which is a multiple of 4, a multiple of 5, and a multiple of 16. The smallest such number will be 80. So let total expense be 80. The amount paid by Bala would be 1/4 of this. So Bala paid 20. Similarly, if the total expense is 80, Chandu will pay 16. If total expense is 80, Z will be equal to 5. So they paid 25. The only amount left is for Isha. 25 plus 16 is 41. 41 plus 20 is 61. So Isha paid 19. Finally, what is asked? What is the ratio of the expenses paid by Isha and Chandu? Isha paid 19. Chandu paid 16. The answer has to be option D, 19:16. Next question. A cask whose 75% volume is filled with milk and water solution. The concentration of milk in the solution is 80%. Okay. A jug is taken and 1 jug full of solution is removed from the cask and replaced by an equal quantity of water. So this is a case of replacement. This process is repeated 1 more time. The concentration of milk in the mixture becomes 51.2%. What is the ratio of volumes of jug and the cask? So there are 2 layers here. First thing you have to see, initially you had 80% purity, and then whatever was left behind in the container, the fraction that was left behind in the container, I'm saying let that be remaining in container, let that be R. This is the new purity now. And because this process was repeated, this is the final new purity now. This has been told to us as 51.2. So R square will be equal to 51.2 by 80, which is 512 by 800. So I can cancel out 32's 32 into 16. Yes. So I'll get 16 by 25, or R is equal to 4 by 5. So in the container, every time what was being left behind was 4/5, which means how much was coming out of the container? 1/5 was coming out of the container. So, and this is equivalent to 1/5 of 75% of cask. This is equal to jug. So jug is equal to 1/5 into 3 by 4 of cask. Finally, they asked me what is the ratio of volumes of jug and the cask. Cask I can bring down here. I will get this is equal to 3 by 20. Answer option B. Next question. A water tank is connected with an inlet pipe. Every morning, the tank is emptied with an outlet pipe. Once the tank is completely emptied, the tank is filled using the inlet pipe at a fixed time every day. If the outlet pipe remained closed, the tank is completely full by 2:30 p.m. Whereas if the outlet pipe remains open, the tank gets full by 5 p.m. If the ratio of the inlet to the outlet pipe is 8:3, then at what time every day inlet pipe starts filling the tank? Okay. Now it may seem like a time and work question. Actually, it is a TSD question. So only when the inlet pipe is working, then you have speed of 8, and let's say the time taken is t. When you have the inlet and the outlet both working, then you will have a speed of 5, 8 minus 3, and the time taken will be t plus 150. T plus 150, because 2.5 hours more is required. I've taken t in terms of minutes. Now the ratio of speeds will be the inverse ratio of times. So 8 by 5 is equal to t plus 150 by t, which gives me 8t is equal to 5t plus 750, or t is equal to 250. So when only the inlet is working, time taken is 250 minutes. And when only the inlet was working, the tank got filled up at 2:30 p.m. So we have to go 250 minutes back, or we have to go 4 hour 10 minutes back. From 2:30, if I go 4 hour 10 minutes back, the answer that I'll get is 10:20 a.m. Nothing else. I'm not even doing 4 hours. I'm simply doing 30 में से 10 minute या तो you're left with 20 at the end. That much we know. So option B. Next question. Leaving home at the same time, Adarsh reaches college at 10:25 a.m. if he travels at 7 km/h, and at 9:30 a.m. if he travels at 18 km/h. If he leaves home at 9:15 a.m., at what speed must he travel to reach the college exactly at 10 a.m.? Okay. Let's see. In the first case, his speed is 7. In the second case, his speed is 18. Let's say the time in the first case is t. Time in the second case should be t minus 55. T minus 55, because he reaches at 9:30, which is 55 minutes earlier than 10:25. Again, because the distance in both these cases is identical, I can happily go ahead and work my way around it. So the ratio of speeds will be the inverse ratio of times. So 7 by 18 is equal to t minus 55 by t, which will give me 70, 18t. 70 is equal to 18t minus 55 into 18, or 11t is equal to 55 into 18, or t is equal to 90. So with a speed of 7, it takes him 1.5 hours. This is in terms of minutes. So here in terms of hours, it is 1.5 hours, or the total distance that has to be traveled is 10.5 kilometers. If he leaves home at 9:15 a.m., at what speed must he travel to reach the college exactly at 10 a.m.? Distance is this. Time is 3/4 of an hour. So speed has to be 10.5 divided by 3 by 4. So S is equal to 42 by 3, which will be equal to 14 kilometer per hour, or option C. That is all for this episode. Hopefully you liked, hopefully you learned something. That will be all. Okay, bye.